to electronics and coding, she was interested in coding, the first thing you have to understand that you're moving in a whole new world. Everything you see there might be 3,000 pixels here, 3,000. Every one of them has got what we call RGB, red, green, blue. So that means 3 controls have to be sent to every 3,000 dots. But it's all zeros and ones. Let's put binary. So you're going to have to learn a whole new set of binary. You should be learning this at school, at least in 3rd grade up. Definitely middle school. Binary equals 0. That's all there is in the binary rule. And the reason being, if you think about it, it makes sense. You're dealing with electricity. I turn the lights on, I turn them off. That's all there is. On and off. So like 1 and 0. 1 is on, 0 is off. Relatively simple. However, in electronics, things get hot, they get cool, so there is a high and a low. So the next is 1 is high, 0 is low. It's all mean the same thing. Like A, B, C, D, or in music you will have A, B, C, lettering notes, then you have do, re, mi, fa, sol. They're all the same, they just have different names. Okay? So, and then you have hexadecimal. We're at the point where the world is just too big for the world we live in. So the decimal system that the world uses, we don't use a lot of it, but we do in science. Decimal, you know what I mean by decimal. 10, 100, 1,000, 100,000, 1 million, right? 10 to the first power, 10 to the second. Have any of you studied that yet? 10? Okay, exponent. The engineers don't use that. They use a system called hexadecimal math. So write down 0, no, start with 0. 0 through 9. This is another thing you've got to get through your head. It's a little complicated, but once you get it, it's easy. And then A, B, C, D, E, F. So the first thing you notice when you're moving into this new world is when we use a decimal system, we use 1, 2, 3, 4, 5, 6, 7, 8, right? For some strange reason, we forgot there is a 0. Well, science hasn't forgotten. So this is 1, 2, 3, 4, 5, all the way up to 16. Put it underneath. In the hexadecimal world, a 0 is a 1. And then they started adding this hexadecimal, because hexadecimal means 16, up to F. F is 16, and that's as far as this mathematical system goes. But strange enough, that can handle numbers that go from here to the moon. Decimal system cannot, or you can't work with it. Think about it if you have, well, let's just take a number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dot, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you try to add those together. It's a mathematical nightmare, right? But thank God you've got what? A calculator. So you don't have to do it. Years ago, the Japanese did it on little balls and pins that moved around. We did it on what in my world, what we call the slide rule, which was approximate, but not what the computer will do. Okay? So this is a hexadecimal system. So everything that you buy every electronic piece of equipment that you buy is going to have a number like that. Okay? So when you switch over in your math that you're learning at school, and the math for what we're talking about that you might learn in school, you have to lock one off. Okay? So this is 0, so write down here, FF. So that means F times F. Therefore, it's 16 times 16 equals 251. Okay? So now, what you have to do is lock one off. You can't use a computer, you'll goof up if you have 256. You have to always lock one off. So if you get anything from this class at all, when you get into computer programming and coding, just realize there's a difference between your decimal system and there. Okay? So now, when you're getting ready to code, all you got is zeros and ones, off and on, high and low. Okay? So somehow you've got to get that so your brain can talk about it, we can write it in books, and you can learn about it. So down here then you have to get some kind of protocol. So, and you both should, if you're in a school here, you should already know. You know what a byte is and a bit? Anybody? Show them a byte. B-I-T. A byte is a 0 or a 1. A bit is a certain number of them. So it's 8 zeros and ones. Okay? So you divide that 8 in half, and now that byte becomes a nibble and a nibble. Like it or not, that's just what they call it. So 4 zeros is a nibble, 4 zeros is a nibble, 8 of them becomes a byte, B-Y-T-E. So from now on, when encoding, everything is going to go that way. And one of these, 8, becomes what we call a packet. Okay, so write that down, packet, P-A-C-K. So anytime you send an A, you're sending probably 8 bits. Okay. Everybody follow me more or less so far? This is tough stuff, but like it or not, you gotta learn it. You can't fight it if you want a real high-paying job in the near future. These are jobs, 67% jobs that will demand you know this well, and it will pay you very, very well. So, that's coding. So now you talk about coding. All coding means is that I'm going to tell that computer somehow to do something. I can tell it with a mouse, I can tell it with a switch in the wall, or I can talk to Alexa at home. I can say, Alexa, turn the neon light off. Or my grandkids come over and say, Alexa, play a song for me. Okay? It's all coding, and you've got some way to communicate. Well, you communicate with these packets. And then you can communicate with what? At home. Wi-Fi, Bluetooth, these are all communication protocol. Right? So we move from the basic concept. This is like the ABC of coding. Okay? So be very, very careful with these. Because if you drop them on the floor, we don't know what they are. So a red one doesn't always look red, the green one doesn't always look green, and the blue one doesn't look red. That depends on the amount of electricity or power you give it. Okay? So on here, it'll tell you what she just showed you. Erase this, Elisa. Now in China, all Chinese students are learning what I'm talking about to you in 3rd grade. All of them. And in English, not in Chinese. Focus. We've got to keep up with it. Okay, now Ohm's law, what we teach within our teaching circle is magic circles, I call them. Ohm's law is the first one you should be learning, and you probably should learn it in middle school. I'm not sure where it is in your curriculum. Have you heard of Ohm's law? No? Anyway, one here, one there. You've got 3 things you've got to worry about. You already know those. Okay? If you take a stream here in Killeen, or a river, okay, whatever, Mississippi River, the water, we use water as an example for electricity. When the water flows down, okay, that's a certain amount of power. Going downstream, you get in a canoe, you're going to end up downstream, right? You're not going to end up upstream. So it goes down a certain way, north to south or south to, depending on what you want. Okay. I'm sorry, this is over here. Okay. So that's called volts, V-O-L-T-S. Okay. This is called Ohm's law. Here we have amperage. Now, have any of you gone white watering, gone down the San Marcos River and got in a raft or a tube? No? You know what I'm talking about? White water? But when you take this stream anywhere, Killeen, San Marcos, where people go and drive forth by the hundreds, they get in inner tubes and they go down. You'll find that as you make it thinner, then you make it do something else. It becomes dangerous. It goes fast. Okay? That will kill you. If you're in Killeen here by HEB and the water is above there and you go in your car's going to float down the stream. That's amps. So you've got to be able to understand what an amp is and a volt. And the next one is relatively easy. Put up your hand. Push, 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 push. That's resistance. Resistance. Everything resists based on the gravity. That's the only thing that holds you on the ground. Okay? So the minute electricity is going to go through here, there's some things that are going to not be so bad. Copper is the best. It will transmit electricity. So almost every wire you see has got a copper thing. So plastic doesn't transmit well. Paper doesn't. Plastic doesn't. Most metals do. Gold, silver, things that are expensive, and copper. Okay? So these are the laws. Now when you see that line, that gives you the mathematics that you need. The line means divide. This line means multiply. So A equals V over R. So have you had enough math to understand A plus B equals C? Yes? Okay. Okay. So you have all 6 equations, or 3 equations for sure, if not 6, we can get out of that circle. So basically, then what you have to do is look in this box here, like she just showed you there. And you can see the different colors. So, different colors, different sizes. If you want a brighter one, you take a bigger one, right? So, take one of each color. Very careful. Try to look and see, make sure you. Just take one in a red one and a blue one. One of each. Those are LEDs. They did not have these when I was your age. You got 3 of them? That's okay, just forget it, take them out. We can throw them away, they're cheap. Okay. Now, this tells you what you need to know. I know, and we know that these are all amps. Now this is what's going to kill you, okay? Most of you will do good in math, okay? The problem is not the math, it's the units, okay? You know what I mean by units? 1 volt, okay? But when it's a millivolt, which these are, this is either 20 milliamps or 0.0. Got it? 0.02. 0.02. So if you call it a milliamp, it's 20, but if you call it an amp, it's 0.02. This is where your math is going to start confusing you if you don't start using it. Okay? Be very, very careful. Take one, get each of them 1 battery. Now, so what we know now is that is 20 milliamps. Now, we could buy it from another company. They might not be the same, but I just happen to know that. So if I'm going to build some stuff to use for the Eclipse, or you're going to build it, then you look on the box and it tells you. It will also tell you the volt. This is again where you've got to start learning what colors are. Colors, the way you learn them in kindergarten, is not what you're going to use in your life. Okay? You're going to use what we call computerized colors. So you're going to take that guy there, and it might have a red one on there, or it could be white. And depending on the amount of electricity you give it, you can make it red, green, or blue. Okay? All depending on the number of volts. But red is going to take more than blue. Okay, volts. So that's called a coin battery. Have any of you ever used one before? No? Now you have to start learning volts. Okay? What is USB? I'm sure you all use USB, right? For your computer, your cell phone, anything you plug in. USB, old USB is 3 volts times to 1. So that's very, very safe. So that's what we tend to work with. Okay? So now take any one of those LEDs, look at it very close, and you find a long wire and a short wire. Okay? Now, this is where it becomes important too. And you learn that as you get older. You have to know if you live in the northern hemisphere, above the equator, or you live in the southern hemisphere, below the equator. So you're going to have to learn north from south. Okay? That's called polarity. Am I pointing that way, or am I pointing this way? Okay? There's polarity. That's North Pole, South Pole. Okay? So you just have to get a figure to do what you want for what you're doing. So that's true of almost everything that we do from now on, encoding electricity, polarity. So generally speaking, it's plus and minus. On, off, plus and minus. So the long one there, these are what you call polarized. That means if you put it into circuit one way, it's going to light. If you put it in the wrong way, it will not light. And you might burn it up. This is where Ohm's law comes in. Okay? So now take one coin and one LED and hold it. And did it light? If not, take it and turn it. Just any one of them. Just one. There you go. If it didn't light, turn it around. If not, throw it away. It was no good. They make these by the millions, so they're not always good. No? Give him another battery then. He might have a bad battery. There. Okay, you got it. Okay. Now you know the long wire is positive. Okay, the short one is negative. Therefore, in all of your batteries, you must have a positive, that's up here, and the negative here. Okay, that's Ohm's law. Here's draw another one. A circuit, on a battery, LED, and a resistor. Battery, long, short, resistor. LED. Up here. Now, each of these demands a certain different amount of power, volts. So, if you've got a 3-volt battery, and these take 2 to 3 volts, try it with 2 LEDs and see what happens. Do they both light at the same time? Good. We're getting there. That means that those 2 LEDs you got now that are lighting take less than 3 volts. So add a third one. Are they all lighting? One of them should go out. You just, right? One goes out, one you add one. That's because you now are above this here. This is 3 volts. This guy could be, write down 3. This is 3 volts. Now 3. Okay. Okay. Some of those take 2.4. So put another 3 volts. Not okay. Look, this guy won't light now. Okay, so this is what a circuit is. This is called a circuit. This is a circle, which means a circuit. Most people do it as a square. This is resistance. This is your hand. This is where you have to take your mathematics here, which is a little complicated, but not above 4th grade level. Okay? And calculate what resistance you need. So usually you need, put down good 110 or 220. So a resistor, generally speaking, in a circuit like this here, for every, let's put a motor here. Let's put a round thing. That's the motor. Okay? Now, you're going to have to recalculate all this based on the motor and the LEDs. So you want the motor turned on. You want to turn it off like we did with the switch. So here now, make the switch. Out, like so, like so. Now, an angle, that's an open switch. So that circuit now, nothing would be on. That's called a closed circuit. Okay? So you take that switch, and I go there, the lights go out, you flick it, and now electricity flows. The important thing in all this is what STEM is, by the way. step is you've got to put all this together in your head. A little bit of math, a little bit of physics, a little bit of that to do almost anything you want. So now when we close this goes in 5 volts. This guy here, it's going to take out 3 volts, so I've got nothing left for my motor. So now let's change this to 9 volts. Show them the 9 volt battery. So 9 volts is a better one to learn with. It's a square. That's the 9 volt battery. So now I have 9 volts. So now motors take a lot of volts. So let's say this guy takes 6 volts. What's down here? 6 volts. I have to end up here with 0 volts, right down 0.